Hey guys, so today we're going to be talking about arc lengths and sector areas. So let's talk about arc length first. So the length of an arc is a fraction of the circle's circumference. So central angle is given in degrees, and we know how to find it. It's something that we learned from last unit, and it's also usually given. So our central angle is going to be over 360. And then we can set that equal to like a proportion, length of the arc over the circumference, which is given to us as 2 pi r. Now, and it's the same way in radians. So if we are given the angle in radians, we can just do it radians over 2 pi, because 2 pi represents a whole circle, and then again set it up as a proportion with the length of the arc over circumference, which is 2 pi r. So we have two ways to do this. So let's look at number 1. So we have 120 degrees. So that means we're going to use our first equation here. So we're going to do our central angle, which is 120 over 360. Then we're going to find the length of the arc, and I'm going to label this as arc length. And it's going to be over 2 pi r. So we know 2 pi, and then it's given to us as our radius is 6. You can find that right there. So let's solve our fraction. So 120 over 360 is 1/3, and then we'll have our arc's length, and that's going to be over our 2 pi times 6. But I'm going to go ahead and reduce that to just 12 pi. It's just going to be easier for us to deal with. So then our last thing is going to be multiplying everything by 12 pi. If I can write it. And I've been writing a little bit too big, but we will have, in the end, 12 pi over 3 equals my arc length. And then our last step is to reduce our 12 pi over 3. Well, 12 pi over 3 is going to reduce to 12 divided by 3 is going to be 4 pi. So my arc length is going to be 4 pi. Okay? But since we started in degrees, let's end in degrees as well. So if I had more room, so we have 4 pi is going to be equal, or sorry, it's going to multiply by 180 over pi, and that will give us 720. So in degrees, our arc length is 720. Alright, so let's move on to the next one. So for our next one, it's given, our central angle is given to us in radians, and that's okay, we can still work with that. So we have the diameter is 24 centimeters, and we want to find the length of CD. So we're finding this arc, and we know that our radius is 24 centimeters. So let's set this up. So we're going to use our radians formula this time, and we're going to have the central angle in radians, which is pi over 3. It's going to be divided by 2 pi. And then it's going to be the length of the arc. Well, that's what we're finding. So our arc length over 2 pi times the radius, which we were given as 24. Okay? So let's go ahead and reduce that. So our fraction goes down to 1/6, and we're left with our arc length is going to be 48 pi. We're going to multiply by 48 pi to both sides. And now we have 48 pi over 6 equals my arc length. And we're going to reduce that fraction. So when we reduce 48 over 6, we get 8 pi. Okay? And since we started in radians, we're ending in radians. So this is 8 pi. Okay, so now we're on number 3, and so I want you guys to set this one up on your own first. So pause the video here and set up the the fraction. Alright, so if you set up your fraction, this is what your fraction is supposed to look like. So if you notice in this problem, instead of solving for the arc, we're solving for the radius. So the radius is our unknown. So from here, I want you to find the radius. So you're going to pause the video here and solve for your radius. Alright, so there are a lot of examples on these notes, and I don't want to just bore you to death with examples, but I'm going to do a couple more, and then these extra ones will be extra practice for you if you would like. This one is finding the arc length, so if you want to do that one, pause the video here and do that. Now the rest of them I'm going to be doing the word problems. I especially want to do number 6 here, so let's do number 6. So we have a circumference of a circle is 25 pi. Find the length of an arc whose central angle is pi over 2 radians. So I'm just going to draw a little picture real quick, because not every time we'll have a picture. So the circumference of the circle is 25 pi. Now I can't really draw that, but I'm just going to say over here, circumference equals 25 pi. Now we have to find the length of an arc whose central angle is pi over 2 radians. So we're finding this length of this arc, and our central angle is pi over 2. Okay? So let's set up our equation. So we have central angle over 2 pi, because we're in radians. And then we have our arc length, which we're going to find, over 2 pi r. Well, if you remember, 2 pi r is our circumference. So instead of having to find the radius or anything like that, we can just put 25 pi. So we are going to solve for this, and we'll get our arc length. But I want you to pause the video here and solve for the arc length. So pause the video here and solve for the arc length. So if you solve for this correctly, you should have gotten that the arc length equals 25 pi over 4 equals my arc length. Okay? Alright. So let's do number 7, and then we'll be done. So find the measure of the central angle in degrees if it's of an arc if its length is 14 pi and the radius is 18. So I'm going to draw a picture right here of what's going on. So that was not good. We have our length of the arc is 14 pi, and we know our radius is 18. And our job is to find the central angle. So let's set this up. So we know it's going to be in degrees, so that automatically tells me, okay, I have to put it over 160. Sorry, not 160, 360. So I'm going to have my central angle over 360 equals the length of my arc, which was 14 pi, over 2 pi r, which is 2 times pi times r, which was 18. And then from here, I just solve. So c over 360, and that's going to be 14 pi, 2 pi over 18. That's going to end up reducing to 7 over 18. And then I'm going to multiply 360 to both sides, and I'll get c to be 140, I believe. Yes, 140. Alright, so that's how you would find a central angle if you had everything else except for the central angle. Right, let's move on to area of a sector. So we have area of a sector. Area of a sector is a fraction of the circle's, you guessed it, area. So we have area of sector is a region bounded by 2 radii in an intercepted arc. So if it's given in degrees and radians, again, we have the same but not really proportion. So we have our angle over 360, and then our radians over 2 pi, and then area of the sector over 2 pi r on both sides. So find each sector area, and we're going to leave our answer in terms of pi. Okay, so I see that we have a 90-degree angle, and we have a radius of 16 inches for that. So let's set up our fraction. So we have 90, and I didn't want that color, 90 degrees, because that's what was given, if I can write, over 360. And then the area of the sector, well, that's what we're finding. And then we have our 2 pi r. So 2 pi times the radius, which was 16 in our case. So let's just simplify and solve. So the shortcut way to do this is just to multiply 2 pi 16 to the other side. So let's do that. So 90 over 360 times 2 pi over 16 is going to be 36 pi over 4 is our sector area. And then all I have to do from here is just reduce that fraction. So 36 divided by 4 is going to be 9 pi. So that's my sector area. All right. So now let's do the next one. So this time we're given our our sector area, and we are given our radius. So, we're given the central angle. It's just off to the side. So we have our central angle as 2 pi over 9. It's going to be over 2 pi. And that's going to equal our sector area over our 2 pi times the radius, which is 8. Now again, we can go ahead and just multiply everything over in one step. So we get 16 pi over 9. And that's my sector area, and then we can reduce 16 pi over 9, and 16 pi over 9 reduces to nothing. Oh, that does not reduce. So my answer is going to be 16 pi over 9. Okay? Alright, so I'll do this last one with you. So then I want you to, I changed my mind. I want you to do this one on your own. So set up that proportion and find the sector area. Pause the video here. Alright, so if you did this correctly, you should get 27 pi over 2. So you're going to set it up as 3 pi over 4 over 2 pi with our area sector over 2 pi times 18. Then you get, if you reduce this, you get 3 over 8, and then the area sector over 36 pi. You solve for your area sector and you reduce to 27 pi over 2. Alright, so now let's move on to number 7, because just like with arc length, not always you're going to be solving for the area sector, you're going to be solving for something else, but using that formula. So we have find the radius of the circle, and it has a sector area of 9 pi, and the central angle is 90. So I'm going to quickly draw a picture. So I have a central angle of 90, a sector area of 9 pi, and we are trying to find the radius. So now that I've drawn the picture, let's set it up. So we are going to have 90 over 360 because we're in degrees, and then we have 9 pi because we know the sector area over 2 pi r, and we are solving for r. So that's how we would set it up. So I want you to pause the video here and solve for r, because I know you can do algebra. Alright, so for number 7, you should have gotten r equals 18, so really make sure that you're continuing to set up things correctly and multiply for things correctly. So lastly, let's do number 9. So we're finding the measure of the central angle of a sector if its area is 5 pi and the radius is 6. I'll draw the picture for you, but I want you to solve for the central angle. Central angle will be C, the radius is 6, and the area of the sector is 5 pi. Now I know it doesn't say radians or degrees, but I want you to do it in radians. Okay, so pause the video here and find the central angle in radians. Alright, so if you did this correctly, you should have found that the central angle in radians is 5 pi over 6, and you could obviously convert that to degrees if you want to. Alright, that's it for today's video. Have an awesome day and stay safe out there.